Hello everyone, welcome back to the Math 0332 playlist. We're rounding towards the end of Unit 1. This involves Unit 1 Homework 7. It's irrational numbers. It's really about taking square roots, what you can't take the square root of. One thing to note is that we have talked about irrational numbers, but one thing that is an irrational number that you might not know is that if it's not a perfect square root, it's an irrational number. So we know that the square root of 4, for example, is 2. That's rational. But the square root of 5 isn't perfect. So if it can't be simplified, that's actually an irrational number, like pi or anything else. It goes on forever as a non-terminating decimal. So square roots of numbers are one of our best examples of irrational numbers. Now, sometimes your irrational number is accompanied by a coefficient. I like to tell myself that square roots are like baked goods. So the square root of 7 is a cookie. So this is really saying 3 cookies down here. But we'll talk more about that when we get down there. If a square root is perfect, then that means something can come out of the square root. Now what I mean by that is if we look at the square root of 121, if you break down 121, it's 11 times 11. That is really that 121 is the square root of 11 squared. Now, one thing that we may not know is that square root and squared are inverse operations, particularly when you're dealing with positive numbers. It's a little bit trickier with negatives, but that means the square root and the squared cancel out, so the square root of 11 squared ends up just being 11, because the square root of 121 is 11. Now, sometimes in the past, you may have remembered putting a plus or minus in front of things. That's not necessary here. When you're just taking the root of a number, you take the positive answer. That is the principal root, because if they want the negative of the answer, they'll put the negative in front of the root in question. So again, by this argument, 49, most people know, is 7 times 7. So this is the negative square root of 7 squared. Here, the square root and the squared will cancel, but there's still the negative in front of the square root, so you get negative 7. So this is how they will imply between the two of them. Now, adding or subtracting roots is just like as if there was a variable there. They need to be the same in order to combine them, which means, again, if you call square root of 7 a cookie, 3 cookies plus 5 cookies is a total of 3 plus 5 cookies, or in this case, 8 cookies. So when you have a common root that cannot be broken down any further, you just add or subtract the coefficients in front in order to get your answer. 7 cookies minus 11 cookies, in this case 7 square root of 7 minus 11 square root of 7, is you group the two numbers in front together times the square root of 7. Well, if you've got 7 cookies and you take away 11, you're now in cookie debt, and 7 minus 11 is negative 4, so you owe someone 4 more cookies. You've got negative 4 square roots of 7. And that's really how this works with adding and subtracting. But we also potentially have multiplying and dividing. The good news about square roots is they interact with multiplication and division very, very well. So for example, when you have the square root of 14 times the square root of 15, you can throw them under, as long as the type of root is the same, you can throw them together under the same square root. So this is square root of 14 times 15. I think in one of our fraction homeworks, we saw that this is 210. So this is the square root of 210. You can check to see if this is a perfect square. However, we know that 210 breaks down into 14 times 15. 14 is 2 times 7. 15 is 3 times 5. There are no shared factors here. So that means they all get left under the square root. Nothing can get out. So that means square root of 210 is as far as you can go. Similarly, division. You can move them together into a single square root. So this is the square root of 63 divided by 7. It just so happens that 63 divided by 7 is 9. So this is the square root of 9. You may know that 9 is 3 times 3, or 3 squared. So this is the square root of 3 squared. And here again, the square root and the squared cancel out, and you're left with 3. So that's something that's really kind of nice about roots. And this leads us kind of to our last homework in this little umbrella. which deals with real numbers. So we've talked about rationals and irrationals. Closure is not super important, but what closure really means is that if you do operations between two, say, rational numbers, your answer is rational. Operations between two irrational numbers would be irrational. They don't necessarily have this property. I'm more concerned with you understanding the other properties that we've talked about. Commutative property applies to both multiplication and addition. Basically saying 2 times 3 is equal to 3 times 2. Similarly, 2 plus 3 is equal to 3 plus 2. Order doesn't matter there. Associative property states that regrouping doesn't change the outcome. What they're really saying is if you have 3 numbers multiplied together or 3 numbers added together, you can take any pair and do them first and the other one second, like with the result, and it will still get the same answer. 2 times 3 times 5 is equal to 2 times, in parentheses, 3 times 5. Same with addition. The distributive property ends up being really important when you're simplifying. That says multiplication can be distributed to addition. This is usually done by showing arrows. So a times, in parentheses, b plus c. You distribute the a to the b and the c, keeping the operation, meaning that this is a times b, keeping the operation in the middle, plus a times c as well. That a will be distributed to both of them. So this tells you how multiplication and addition interact with each other. And the last two properties are somewhat useful. Identity, how you don't change the number at all. And for that multiplication, when you multiply a number by 1, it stays the same. For addition, it's adding or subtracting 0 leaves you the same. Multiplying or dividing by 1 leaves you the same. And then the inverse is how you get back to the identity. So that means 1 is our multiplicative identity, 0 is our additive identity. Inverse is how you get back to your identity. For example, what do you need to add to 5 to get back to 0? Well, you need to add negative 5. So this is saying that if you add a number and the negative of that number, you'll get back to 0. For multiplication, it's a little bit trickier. To multiply a number, you want to multiply by 1 over that number, so those things will it's like a over 1 times 1 over a, will give you a over a, which reduces to 1. Now the only thing you need to note is that 0 doesn't work. 0 does not have a multiplicative inverse because there's nothing you can multiply 0 by to get back to 1, because anything times 0 is 0. So when you're categorizing numbers, so basically real numbers can be broken up into 2 types of numbers, rationals and irrationals. Rationals also have potentially the integers, are some of the rational numbers. Whole numbers are a part of the integers. Natural numbers are part of the whole numbers. If it's something down here, it is all of the things on the tree up above it. So you'll have some questions about classifying. There will be numbers that are integers that are also rational numbers, and it'll ask you to pick which one. Now, some of the other homework questions ask you which property allows the following to be true. So what allows 1 plus 5 to equal 5 plus 1? They changed places, so they commuted. So this is the commutative property. And since the operation was addition, we would say this is the commutative property of addition. So then we can roll through these. What makes the square root of 12 times 1 over the square root of 12 automatically 1? Again, we're multiplying by the inverse. So this is the multiplicative inverse property. It said a times 1 over a was equal to 1. What allows a times, in parentheses, d plus 1 to be ad plus a? Again, this is the property that allows us to multiply the a, distribute the a over addition. So this is the distributive property. Since the distributive property is about how multiplication and addition interact with each other, there is no distributive property of addition or of multiplication. It's just the distributive property because it talks about how they interact together. And 4 just talks about how when you have 3 things multiplied together, it doesn't matter where the parentheses are or the order you do it, you get them the same. So it doesn't matter who you're associating with at first, it all ends up the same. So this is the associative property. And technically we could also say, because it's dealing with multiplication, we could say the associative property of multiplication. And this should actually end all of our notes for Unit 1.